Okay, so let's get started. We're going to be taking a look at doing a quick demonstration of our launch control that we've covered in our previous training tutorial. So I wanted to go and demonstrate this on our in-house test vehicle, which is a Honda K24 engine. It's naturally aspirated. We can see some of the effect by setting up the ignition and some of the spark cut range, as well as some of our other parameters such as our fuel trim when we have our launch control enabled and engaged. So let's go in and take a look at this real quick. I'm going to move from my fuel tuning area here. I'm going to jump over into our motorsports area. Now on the very first page we have our launch control. Let's go over our details here real quick before we fire up the engine and do our initial test of our launch control. So we can see in this case, I'm not using a launch switch or a launch aim switch. So I'm basing my launch control not on a trim pot to give me variables for having different launch RPMs and not having an overall master toggle switch to turn launch control on or off. We're basing that within our control table with vehicle speed, as we're going to find here, go through some of our parameters. So driver launch switch we're not using, driver launch aim switch we're not using. Now the driver launch mode is showing that we do want it enabled, so everything here is turned on and accessible. Now the activate here, I want this to turn on regardless of my exhaust temperature. Naturally aspirated, I'm not really worried about AGTs or exhaust gas temperature. I'm going to leave this at 0 Celsius. Now coolant temperature we can see right now is at 0 Celsius. And maybe something to consider, I'm going to say I have to be at least 30 degrees Celsius for this to engage, just so I have some heat build up in the engine and I'm not too hard on the engine. This is a built engine with forged pistons. I definitely wouldn't want to go ahead and enable the launch control when the engine is cold. That could scuff the pistons and create blow-by. The entry, so this is going to be how we actually go into the launch control. We have to be above 60% throttle, and to come out of the launch control, in this case, we have to drop below 40% throttle. So that's a pretty reasonable throttle threshold to engage it. The next thing we have here is our ignition timing advance. This is going to be the minimum that we're able to bring our ignition timing down to within the control. Now, because we're naturally aspirated, it's not going to make as much of a difference in terms of having a minimum here that's really aggressive. With a turbocharged engine, if we're trying to maintain and hit a certain desired boost target, then it would be important to have a pretty low minimum value in here. I'm going to put my value at something like -5 or 0 would even be sufficient because naturally aspirated, the ignition timing retard isn't doing a whole lot for us. We don't have a target boost we're trying to reach. So naturally aspirated supercharged, this isn't as much of a concern. I'll keep it at -5. That should be more than sufficient in terms of the minimum adjustment it can go down to. Now the control here, we find some live parameters, air. That's the difference between our desired launch engine speed and our actual engine speed. That's going to be able to calculate. The proportional gain and integral gain is going to be the contribution factors to our ignition timing. So we can see here the proportional is able to be adjusted and the integral is going to be able to be adjusted. We'll have to see how this is going to play a role here. It's probably going to have minimal effect on the naturally aspirated engine. Turbocharged engine, it would make a pretty large effect getting up to the desired target boost. Now the engine speed table here, we can see this is a pretty simple table. It's based on vehicle speed estimate. I am using my front wheels for the vehicle speed on my transmission case. I've wired in the vehicle speed sensor to my Motec, and that's what I'm using for my vehicle speed source on this vehicle. So vehicle speed estimate is going to be based on that. You can find the table here, essentially commanding a launch RPM up here to about 3 kilometers per hour. Above that, it's going to be turning it off. So we see that it goes to a 10,000 RPM, 4 kilometers and above. This just makes sure I'm able to bypass and disengage the launch control because, again, we don't have a switch that's used to toggle it on or off. We're going to be using vehicle speed to turn it off for us, doing an automated process. Definitely more ideal this way. So the launch RPM I'm going to be programming here is at 5,000 RPM. This is really going to depend on the engine you're dealing with, the traction you can get when you launch, your wheels, your tires, the surface that you're launching at, if it's a drag strip versus the street, front wheel drive versus rear wheel drive versus all wheel drive. It's going to be really left up to you it's going to work for your vehicle. I would recommend to probably go a little bit higher than you suspect initially so you don't get a bogging and you break something in the drivetrain. I'm going to go at 5,000 RPM. That's more than sufficient for my engine here just to do some testing to feel this out. Next, we have our limit, which is going to be something we're going to be able to take a look at, and the margin here is going to be set here at 500 RPM. Now, we likely want to go ahead and shrink our margin. What this is going to say is it's going to be the ignition control when we're talking about a proportional integral and the minimum here. This is going to be the range it can control in. So if I have my cut set at 5,000, that's where I want to have my launch speed. It's going to be able to have a margin of 500 RPMs in order to play with the ignition timing to be able to control us at the speed. I want to go and lower this down a little bit. I'll probably keep it a little bit tighter, maybe 100 to 200 RPMs. So my launch RPM is closer to the program target here. There's going to be some fluctuation, some deviation there, but we want it fairly close. I'm going to put it at a value of 100. That should be good. Now,
thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.